Good afternoon and welcome back to this main room. We're going to kick off this afternoon's program. And in order to start the afternoon, it is my great pleasure to welcome Caspar Herzberg, who is the CEO of AVEVA and a member of the executive committee of Schneider Electrics. And Caspar is going to explain to us and to give a keynote on how we're going to leverage AI to get competitive advantage. Caspar, the floor is yours. Thank you again for being here today.
Thank you. It is always a challenge to speak right after lunch and to compete with lunch, really, but I'll do my best to make it very meaningful for you. So thank you very much for inviting me here and for allowing us to address you. I'll come pretty much straight to the point. For those of you who don't know AVEVA, we are an industrial software company, one of the larger ones, now part of the Schneider Group. If I leave you with a couple of very simple and I think quite, for us, important facts, important for the industrial application of AI, right? About 90% of the world's Fortune 500 companies use AVEVA, either in SCADA or, so meaning in operations management or in design, or a lot of them in the historian for time series data. And clearly, time series data is a very important component to make AI successful in the industrial world, where probably most of the actual use of AI and the use cases of AI that I understand that you have discussed this morning are going to take place. We operate in most markets, from energy to power, to food and bev, to chemicals, infrastructure, food and bev, and so on. And when you link that to sustainability and the challenges of sustainability, meaning reducing energy consumption while still growing, then you will see that doing that smartly, doing that responsively, is an important part of, of both making the world a better place and using technology in order to do so. Okay? So much about AVEVA, don't worry, this is not a shameless marketing pitch. This is just so that you can put us into context. Okay? Now, the opportunity, I think, is clear. How can we do more? How can we do more faster? Right? How can we cut out the human from certain processes without replicating the errors, the issues, the mistakes that the human is making? And how much of that is possible, right? This is the promise before us. The promise is, of course, to cut the energy consumption, the efficiency by 20, 30, 40, potentially 50%, right, in industrial processes. And if you know that most of, or a large part of global warming is either an industrial process or the heating and cooling of buildings, then you know that this is an important space to focus on. Okay? Now, again, this is the challenge is always when you talk to an audience of experts and you come with the general marketing slides. This is, but we all know that the amount of industrial data that has been created in the last 30, 40, 50 years is exponentially growing. I'll talk about that in a second, right? And that the possibilities that this data gives for industrial processes, but also for the usage and the usage by engineers in their decision processes is something that is akin to a data revolution, at least in theory, right? At least in theory. In practice, we will come to that in a second. Now, the number I want to leave you with that I like, so I had to look up what a zettabyte is. Fundamentally, it's very, very big. So it's more zeros than the human brain can comprehend. And this is the amount of industrial data that has been created now. That sounds really, really good until you realize that more than 70% of this data is not used. And these are not cat videos and TikTok videos and stuff like that that sits on data centers. This is all data from time series, vibrations of machines, the heating, temperature information, and so on. Yet, 2/3 of this data is not used, is just out there, hanging out, right? We do know that those companies that are able to access at least part of that data successfully, right, do better than those that do not. Again, you're not going to be surprised by it. What may surprise you is that it's only 40% of global companies that are able to do that, that are able, I know that this morning you talked about ecosystems, that are able to bring ecosystems together, digitizing the ecosystem and using the data across the supply chain to plan, to execute, and to improve the operational processes, right? That's less than half. And from that, those companies that do it, they grow better, they are more profitable, they do better than those companies that don't. Again, this is an audience of people who I believe, right, in raise, if you like. You'd be surprised how many people still don't, right? So there is a large part out there that are quite caught up in the old way of doing things. And the reason for that is actually a simple one, right? The challenges, I mean, everyone will tell you there are challenges with data and the data that goes into AI, the data that goes into automating industrial processes. It's true, right? What I think we spend less time on is to look at why these challenges persist and how much of these challenges are simply down to, oh, you have to do better data keeping, you have to bring you have to hire data analysts, data scientists. This is one of the fastest growing job groups. But the truth is that there is something deep in human nature that makes us reluctant to share data out of our silos. There is a reason people build walls. There is a reason why in big organizations people build walls. It's to protect themselves from their management, to protect themselves from any potential changes, right? So the reluctance to share data, other than nominally, and the reluctance to automate is linked to a fundamental human need for protection. And that actually, I think, has rather big ramifications when we try to automate processes, because if we don't make the people that work in organizations comfortable with the idea, not just with AI, but fundamentally comfortable with the idea of sharing all of their data and allowing easy access within the company, then how will it happen between companies? So this is a very important point to consider, especially as, of course, we know that especially on the large language models, AI creates as many errors as it does solve, and separating these out again is an important part, an important activity that needs human insight and human instinct. The other ones are more easy, the inconsistent data, the different formats on data. Most of that can be worked through, as can the lack of good spaces for people to collaborate, virtual and remote collaboration in a clearly defined and easily accessible space, working on that data. But I come back to the fundamental initial part, right? Understanding why silos are there and solving that is the key to making not just AI, but the general use of data in industrial and any other process a reality. Now, at AVEVA, we have been working on AI for quite a while, right? We have been working specifically in the operational side on using operational data, time series data, to power predictive analytics. Yeah? So algorithms that predict maintenance failures that solve these maintenance failures. So this we have been doing for 10, 12, probably 12 plus years now, right? Now we have the emergence, of course, of general AI, of the large language models. And our task now is to, and our vision now, is to bring these two together so that we infuse the predictive analytics with the power of large language models and make that available as a product, okay, to the market. So this is where we are now. Now, the key here is, just to give you some case studies and some data, before I show you a demo, because I think the best way of seeing this is to actually see what we are working on. Yeah? The key here is that we have case studies now where predicting a turbine failure, for example, for Duke Energy in the United States, a utility, can save, you know, per saved event, meaning you predict the event correctly and it doesn't happen, up to $90 million per event. So it's extremely valuable to get these things right. And the failure quote is nearly not existent. And that is because, of course, the data that goes into this type of AI is limited, right? It is the data from machines. There is not a lot of ability for the human to, or for the human to enter wrong stuff, or for the machine to hallucinate. Now the trick is, how do we mix this with the other idea? Now I'm going to go into first a case study and then a demo. So we have been using for a number of customers the same type of Gen AI, so the same type of predictive analytics on wind farms, on predicting when turbines go down. Okay? Now you all know that turbines, when they stop, are difficult to maintain. And now I will ask you, why is that a problem when the turbine stops on a wind farm? That's true. But that's not the only one, because it's actually quite expensive and difficult to find the humans that are willing to climb up the tower. It's as simple as that. And believe it or not, and I don't want to go into cultural differences, one of the biggest reasons for the rejection of wind turbines in Texas is that there particularly it was hard to find crews that are willing to climb the pylons, right? So there is quite so it's not just the power outage, it's not just the issues around you know, the lack of generation. There is the fact that there aren't enough people willing to climb up there in order to repair something. So it is actually quite critical for the successful application of, or the successful usage of wind turbines, that you predict very well when they will fail. And that's where AI and predictive analytics play an outsized role, you see? Because you have sparse maintenance crews, making them go to the right turbine in advance is actually quite a critical task. So the question we had is, now looking at the Pi systems data that powers the demo, the use case that I just talked about, right? So the vibrations, the changes in temperatures, how can you, in an environment where where not just the maintenance crews are sparse, but also the engineers that have to look at the screens and deduct and determine what needs to happen, are becoming sparser? Because again, we have a generational shift. So people have you know, not everyone wants to work in a remote location, whether that's a wind farm or any other industrial asset. And not everyone is going to invest the 10 years plus that it takes to become truly knowledgeable, learning about how that works. So there is a limited workforce. So our thought was, how can we support by making very different parts of by bringing different parts of systems, asset information, other information together in one place, how can we support the decision making, and how can we automate much of that? And now I'm going to take a risk, which is I'm going to show you a demo as a video, which is always particularly difficult, of course, but in the setup, I think this is the best we could do. So I will do my best now. So imagine you are working in a power company, yeah? The wind turbines are out in the sea. You see this here. I see that NVIDIA is here. This is something we worked on with NVIDIA together on parts of the technology here, right? So clearly, wind turbines failing, big issue. We just discussed that. Okay. So this is based on actual information of a power operator in the North Sea that we have put together. And by the way, you see the quality of the graphics. That is to attract the younger generation into this field. Now what you see here is the operations control room by AVEVA software, right? You see here on the left-hand side the various assets, and you see a lot of high-level information that comes from assets, like wind turbines, like others, including the actual operational information of these assets, right? You then go into here turbines. So in this case, you can see on the right-hand side there is an issue with the turbine, and the operator can go to this turbine. Okay. Now it could anything that has gone wrong with this turbine, right? He is then able to look at the turbine, right? He is able to go into the life size. First of all, you saw the life-size depiction of a particular turbine. Then he goes into the time series information that forms the basis for predictive analytics of that turbine and looks at the different issues there. Now, all of this is still a very experienced operator, of course. But now imagine, as he looks at these screens and he tries to determine what does this really all mean. And he goes and he asks the industrial AI assistant that is now taking the power of large language models and the power of predictive analytics and brings those together. This is something that we have done. And he is here able to ask not just the what, but also the why, objective-based questions. You'll see that in a second. And basically asks the assistants for what does the fall in output and mean. Okay, the AI assistant then goes into the manual and summarizes the information of the manual, right? And then let me see if I can just too bad. So that was a bad mistake. So let me explain to you the rest of the demo. Very, very briefly. The operator goes into the manual information. The AI assistant summarizes the manual information, right? Because on the average plant, there are 50, 60, 70 manuals. You know that. Sometimes more with different generations of software. What the assistant does is summarize the information from the manuals. Okay? And then give advice, because it's an assistant, it's not a fully automated process, of what the operator should do. It then allows the operator to go into the detail of the 3D model, and in the 3D model, he compares, or she compares, the issue with that he sees written with what was with what is in the 3D depiction of the interior of the turbine, and can then collaborate with another avatar of someone in a different location on replacing the faulty part. Now, what have I shown you? I have shown you predictive analytics, so time series AI that predicts a failure. I have shown you an industrial assistant that summarizes written information, and I've shown you how these two come together to support decision-making by an engineer who, in this case, doesn't need 12 or 14 years of training, but can probably do it in a year or two on a wind farm. This is something we're launching in June as a product. It is one of the first AI products in the industrial world. We're very excited about it. Now, it's clear to me that this seems modest, but I think we think that real use cases warrant a modest approach. Because in the end, what I have shown you is something that we can do with 0 faults. And that is because the data, coming back to the silos at the beginning, that goes into this is limited to industrial data, is limited to manuals, and is limited to industrial data and manuals, right? So that is for us a real application of AI in the industrial world. Thank you for your attention. I hope this did not bore you, and I hand back to you. Thank you.
Thank you very much, Caspar.
Pleasure.
It's been a pleasure. Well, thanks a lot, Caspar. Great example of industrial approaches and implementation.